Right, so welcome everyone. There's people online and there's lots of other people in the room. So my name's Warwick Dellow. I'm a Professor of Endocrinology and Metabolism and Head of Division. And I've got the pleasure of introducing Niamh. So before we start, I've got a bit of boring stuff to do, which is emergency fire. There is no planned fire, hopefully. But if it does happen, then out the door to the right, to the meeting point. Okay, so what can I say about Niamh? Yeah, it's a bit like a wedding, isn't it? So I've known Niamh in a professional capacity probably about a quarter of a century, I think. She's quite shocking. She's obviously now Professor of Endocrinology at Imperial College. She's a consultant in Imperial College Healthcare Trust. Clinical work is at Charing Cross, mainly in pituitary disease, and she's done research, which I'm sure she's going to talk about, basic science and all the way through to patients, and she's a big advocate for patients. And I think it would be fair to say, if you had a choice of me or Niamh, I would prefer Niamh to treat me. So that says something. She's also, as you probably know, heavily involved in teaching, and I think a real star for the department and a real role model. So without further ado, over to Niamh.
Thank you so much for joining me this evening. Thank you to those of you who are online. Thank you to those of you here at South Kensington. I'm so grateful for you all to be coming to this lecture that I'm giving, my inaugural lecture, so welcome. Okay, so I'm what's called a clinical academic, which, as the name suggests, means that I'm involved in some clinical work and some academic work. And as Waldrit mentioned, my clinical work is at Charing Cross Hospital for the NHS. Charing Cross is pictured here. This is actually a relatively glamorous picture of Charing Cross. I want to defend Charing Cross because it's such a special place to work. It's definitely not going to win a prize as the most beautiful building in West London, but it's a really special place to work. You know, many of us in the audience work there. Delightful group of staff who work tirelessly to look after patients, and so I really enjoy my time there. And then my academic sessions are at Imperial College London, on this campus often, not necessarily in this lecture theatre. I'm usually found round the corner in the Sir Alexander Fleming building. Now, I suppose when I was thinking about why did I choose medicine, actually, I'm not really sure that I did choose medicine. I think medicine very much chose me. And what I mean by that is that I didn't really know anyone who was a doctor when I was growing up. But I sort of remember being about 13 or 14 and thinking I really wanted to be a doctor. And I was very lucky because my parents are incredibly supportive and in fact really, didn't push me towards anything, supported me very much to do the best that I could and to go after that dream. And I do remember really worrying about my medical school interviews and thinking, gosh, when I'm asked, why do I want to do medicine, I'm going to find that so difficult to explain. And I am conscious that my family here, and sometimes I do come through the door quite frazzled after an NHS clinic and slightly stressed, but for the most part, I've found clinical medicine incredibly satisfying and rewarding, and it's been a great career for me. So I went to medical school in Liverpool, had a fantastic time. Can't look at this building without feeling a little unwell, because that's where I did all my undergraduate exams. And then I'm conscious that probably less than 50% of the people in the room will know who this is. But this is a Liverpudlian, it's very, very much going to be the older generation. So this is a Liverpudlian comedian called Ken Dodd, famous for not paying his taxes, but also did give some money to Liverpool Medical School for elective awards, and I was lucky to be the recipient of one of these. And actually, when I was going through my junior doctor training and I was going for jobs, the Ken Dodd Elective Award was always a question in my junior doctor interview. Okay, so I did 2 years of undergraduate medicine, and then I was asked whether or not I'd like to do a BSc in physiology. So Here at Imperial, we have a 6-year MBBS BSc programme, and the BSc would be an integral part of that. For me, I would be taking a year out of my cohort and rejoining a new cohort. So I did think a little bit about that, but I really, really loved physiology as an undergraduate, and I guess that's really stayed with me. So the physiology department at Liverpool was very strong, really inspirational lecturers, and I think for lots of undergraduate medicine, physiology really made sense to me in a way that possibly anatomy and biochemistry felt like a bit more of a slog. So without me knowing at the time, I think the stars started to align for me to be an endocrinologist. And this is because I had a really wonderful supervisor for my BSc project, and his name was Professor Robert Burgoyne, and his big interest was in the adrenal medulla. So just to show you here, this is the adrenal gland, and each of us have an adrenal gland on top of each kidney. And the outer layer of the adrenal gland, called the cortex, makes a hormone called cortisol, which I'll talk about a bit later. And the inner part, the medulla, makes our fight or flight hormones, adrenaline and noradrenaline. And so this research, supported by Professor Burgoyne, was looking at the release of these fight or flight hormones, adrenaline and noradrenaline, from the adrenal chromaffin cell, the medullary cell. And he was interested in the machinery that moved the granules to the cell membrane. And as I say, this is the release of hormones, this is endocrine physiology. I just didn't really know what endocrinology was at the time. And I loved that BSc project. I think that really sort of ignited an interest for me in research. And as I say, I think on balance, the stars were starting to align in terms of where I was headed. So I finished my BSc, I returned to medical school, and I graduated from undergraduate medicine. And then in those days, you did a pre-registration house officer for a year, which I did in Liverpool. And again, when I sort of reflect on my career, what I've been really lucky in is that along the way, there have been key people who have really given me some really valuable advice at critical times. So when I was doing my house officer job in Liverpool, I worked for a really lovely, very eminent clinical pharmacologist called Professor Alistair Breckenridge. And I mentioned to him that I wanted to come to London. No disrespect to Liverpool at all, but I'm from near London and I'm an only child, so I really wanted to be able to come a bit closer to home, I think, for the next chapter of my life. So I asked him for some advice, and he said to me, "Oh, I would definitely go and work at the Hammersmith if you're moving to London." Now, of course, I'd never heard of the Hammersmith, and that was probably a good thing, actually, because it certainly didn't make me feel intimidated to go and look for a job there. So I diligently applied for my job at the Hammersmith, and he mentioned to me that the Hammersmith really placed a lot of emphasis on research. So whatever I did, when I went for my interview, I needed to be prepared about research and have some questions ready. So I mean, goodness, I sound like such a dinosaur when I say this. There was no internet in those days. So I had to go, I remember it so clearly, I had to go to the hospital library, I had to photocopy an article from Nature. I remember it as if it was yesterday, it was on asthma, and I diligently read that article on the train on the way down to the Hammersmith. And then, in fact, I was interviewed by this gentleman, Professor Steve Bloom, who became a really important feature in my life in terms of being both a clinical and an academic mentor. And I remember Steve very, very clearly on the interview panel, white coat, asked me about research. I was able to talk about my Nature paper on asthma, and I was offered a job. And the job was a 12-month post, and it was 6 months at Queen Square doing neurology, 6 months at the Hammersmith. 3 months cardiology, 3 months endocrinology. So off I went. I think in terms of neurology, although it was an interesting experience, lovely place to work at Queen Square, really interesting medicine and lovely people, I think I felt that neurology probably wasn't for me. And then I moved to the Hammersmith and I did 3 months of cardiology. And actually I loved cardiology. I had very inspirational consultants and registrars. I really enjoyed it. And then one day I was on the coronary care unit towards the end of the placement, and I got a bleep. And I answered the bleep, and it was a consultant who said he was Dr. Meeran. I said, oh, okay. So he said, yes, I'm going to be supervising you for your next placement. Are you interested in doing endocrinology? And I said, oh, no, I want to be a cardiologist. So he said, oh, okay. And actually, looking around the room, there are so many of us who have worked for Karim, and the tide has turned, and we've been inspired to become endocrinologists, and that certainly happened to me. That job was very, very busy in endocrinology. Interestingly, in those days, we didn't have a nice clinical investigation unit like we have now. So as the SHO used to sit in clinic in a room and do the insulin tolerance test and all the dynamic function testing. But I definitely felt that that was where I was headed. And then once I completed my junior doctor SHO training, I went back to Steve and Karim, and I asked if I could specialise in diabetes and endocrinology. And I was supported by them. I got a training post in diabetes and endocrinology in North West Thames, and then Steve was very helpful in facilitating my application for a Wellcome Trust Clinical Training Fellowship as a PhD fellow. And Steve has a big interest in the hypothalamic regulation of appetite. Now, in terms of why I chose this paper for my PhD, there are multiple reasons, actually. So the first reason is because it reminds me of the clinical questions that we have all the time and how we can answer those from research. So endocrinologists see a lot of thyroid disease. The thyroid gland sits in our neck like a butterfly and makes thyroid hormones, and it can sometimes become overactive and too busy. And that's called hyperthyroidism. And it's very common in patients with hyperthyroidism to feel very stressed, sweaty, everything's sped up, their basal metabolic rate sped up, they lose weight. And then as a consequence, we presume in endocrinology, because of the weight loss, they eat a lot more. But we know that a small percentage of patients with an overactive thyroid actually gain weight. So the question really was, could thyroid hormones directly stimulate food intake? And we showed this in this paper with a series of experiments showing that the active thyroid hormone, triiodothyronine, stimulated food intake via the ventromedial nucleus, which is a specific important nucleus in appetite regulation in the hypothalamus. So there's another couple of reasons actually why I've chosen this paper as well. So firstly, there are people on this paper, authors on this paper that I still work with. So Waljit mentioned that he's known me for a really long time, and he has. We were both PhD students together. The first author of this paper is Wing Mei. Wing Mei has been a friend and a colleague ever since that time. I work with James Gardner still in undergraduate education. So lots of sort of really meaningful friendships and professional working from my PhD. However, I do remember when I started my PhD feeling quite at sea. And what I mean by that is that I'd come from a very busy clinical job. I was a registrar at Ealing. I felt like I was relatively competent. And then I came into the laboratory. I didn't know one end of the pipette from another, didn't know how to do a calculation. And I did feel quite intimidated. I think by the time I got this paper together, I think I probably was a bit more with it. But there was always someone who was so kind to me, always so sweet, and really the best thing that's come out of my PhD. And that, of course, is my husband. So much more important than any of the papers, okay? So I returned to clinical medicine, and I guess what clinical medicine then sort of gave me, with my PhD under my belt, was this ability to really think about different questions that I might be able to answer, questions that I saw in clinic, and what kind of research would be interesting to look at them. So what I wanted to talk to you next about is something that the endocrinologists in the room will be familiar with, which is something called Cushing's syndrome. And it's an endocrine condition that we see, not that common, and it's due to very, very high levels of a hormone called cortisol. Now, cortisol is getting a lot of bad press recently on social media. I'll come to that a bit later. But cortisol in very, very high levels, either because of a tumour of the adrenal gland making too much cortisol, or a tumour of the pituitary gland driving the adrenal gland to work too hard, causes Cushing's syndrome. And these high levels of cortisol are very detrimental to patients. And particularly when we look at patients with Cushing's, we see this very characteristic phenotype, central weight gain, these often very tender purple stree or stretch marks, and impaired glucose tolerance, diabetes and high blood pressure, hypertension. So within endocrinology, we find Cushing's syndrome quite complex. And you might think, there's nothing complex about this, it's very straightforward, it's very obvious to diagnose. But the difficulty is that I'm showing you a very extreme version of hypercortisolism. But actually, patients often present with much milder disease. They often may just present with some central weight gain, with impaired glucose tolerance or diabetes and high blood pressure. And we know that our population is increasingly overweight or obese, and with that often comes impaired glucose tolerance, diabetes and high blood pressure. So it's often difficult for the endocrinologist to work out what's Cushing's and what isn't. And the second problem that I think is particularly relevant for Cushing's syndrome is that some of our diagnostic tests are quite limited in their diagnostic accuracy, and so it's quite hard for us sometimes to work out what the diagnosis is. And it's really important to get that right, because we don't want to miss the patient with Cushing's, but we don't want to give a normal person an unnecessary operation. So when I returned to clinical medicine, I found this paper. I thought this was really interesting. The last author is someone called Lynette Neiman. She's an amazing woman who's a sort of international expert, actually not just in the US, on Cushing's. And she and her group had published this interesting paper looking at proposing a new, much more accurate diagnostic test for Cushing's. So she took patients with a specific type of Cushing's disease, so a pituitary tumour driving the adrenal glands to make too much cortisol. And she took two groups of people. She took 20 healthy volunteers and 20 patients with mild Cushing's. Now, the first test that she did or that the group did, was a test that we use all the time in the diagnosis of Cushing's, which is called a low-dose dexamethasone suppression test. And just to explain what that is, dexamethasone is a steroid, so if I took a tablet of dexamethasone this evening, I would switch my cortisol off tomorrow morning. But if you have Cushing's and you're making too much cortisol, you don't switch your cortisol off in response to dexamethasone. So the top panel, the top panel here is our normal volunteers who have all switched off their cortisol in response to dexamethasone, as we'd expect. And then this group here are the Cushing's disease patients. And you'll see that 4 patients with Cushing's disease have actually switched off their cortisol and been misidentified as normal. And that's obviously got implications for patients. And so what she proposed was that we added on a second hormone at the end of that test, a hormone called corticotrophin-releasing hormone, which comes from the hypothalamus, and that if we gave that intravenously at the end of the test, it would give us 100% diagnostic accuracy. So in other words, if you look here, both groups are beautifully separated. So that was very encouraging and exciting. That certainly helped in terms of us helping patients and identifying patients with Cushing's more accurately. So I went on and looked at all different types of Cushing's syndrome in this study, and I in fact showed that this new diagnostic test was unfortunately not as accurate as we once thought. In fact, it was less accurate than the test that we have already. And in fact, I think this was very important at the time because we moved away from this test and towards other investigations that we now use for Cushing's. Okay, so I finished my registrar training in diabetes and endocrinology, and 2007 was a big year for me. So I was promoted or awarded my consultant position, and that was at Charing Cross. And then I was awarded an NIHR Clinical Senior Lecturer Award shortly afterwards. And that was a grant that was designed to try and maintain clinicians in academia, which is where I've got this sort of 50-50 role that I have to this day, where I'm sort of 50% NHS and 50% Imperial College. And I also, as part of that consultant post, became chair of the Imperial Pituitary Multidisciplinary Service. And in 2007, I also got married. So as I say, lots of big things in 2007. So I've mentioned the pituitary gland a few times, and I feel like I now need to talk about it because the pituitary gland and I have got a very special relationship. It's very important to me clinically and sort of also with the research that I do and a lot of the education that I do, particularly for patients. So again, I'm conscious that not everyone in the room is an endocrinologist, so I'm just going to start and show you that here in red is this bony dish at the base of the skull called the sella turcica or Turkish saddle, and that's where our pituitary gland sits. It's called the master gland because it makes lots and lots of different hormones, and this is what it looks like on MRI, this white bit here. It's hanging from a stalk centrally, and this stripe across horizontally here is the optic chiasm, and that controls our eyes and what we can see. And that's important because, as you can see here, we've got me, this is an example of me standing at the bottom of another lecture theatre at Imperial that I lecture at, and that's me with normal vision. If I had a pituitary tumour squashing my optic chiasm, then I could run into trouble where I can't see properly. And these pituitary tumours are not cancers, okay, but they can cause trouble for patients because we're talking about a very small area. So they can squash the optic chiasm, as I say, and cause problems with vision. They can stop the pituitary gland from working properly, so it doesn't make the right hormones. Sometimes these pituitary tumours can make too much of a certain type of hormone and also cause problems for patients that way as well. And this is just a slide from undergraduate medicine as well, reminding everyone how important the pituitary gland is. No wonder it's called the master gland. It controls all these different body processes. This is where you'll find me on a Tuesday lunchtime. This is us at Charing Cross managing complex pituitary disease. And I'm chair of the Imperial Multidisciplinary Pituitary Service. As the list suggests here, multidisciplinary because it's a team of wonderful people who work very closely together to try and do the best for patients with complex pituitary disease. And I think we're a fantastic team. We work really well. I think we're very respectful of each other. And I think really my role is just to pull it all together and have a concrete plan for the patient at the end. So I really enjoy that part of my working week. So I thought I might talk about a relatively common for us pituitary tumour that makes too much of a certain type of hormone, and that's the prolactinoma. So prolactin is secreted from the anterior pituitary, and it's responsible for the regulation of breastfeeding, lactation. And the regulation of prolactin is under the control of dopamine from the hypothalamus. So dopamine comes down from the hypothalamus, down the pituitary stalk, into the pituitary, and dopamine inhibits prolactin. So if you've got less dopamine, you've got more prolactin, and as I say, prolactin is important for lactation. So we can have tumours of the pituitary making too much prolactin, prolactinomas, and that's what you can see here. So this is all tumour, as I say, not a cancer, but you can see how this is going to cause problems for a patient. This is the optic chiasm stretched right over the top. This patient had difficulty with her vision, couldn't see the computer screen properly, had an MRI, and then someone measured a prolactin. And as you can see here, the prolactin was up at 60,000. So the upper limit of the reference range for a woman would be 550, so a huge elevation in prolactin. This is a prolactin-secreting tumour. Now, you might think, oh gosh, you know, this patient needs to see a neurosurgeon, and our neurosurgeons are integral parts of our pituitary MDT. But I guess the most important thing to remember is that these pituitary tumours, prolactinomas, can actually be managed medically, and they can be managed medically by a drug called cabergoline, which is a dopamine agonist. And I've just got a schematic diagram here to show you how cabergoline works. So this square here is a lactotroph, and this makes prolactin in our anterior pituitary. And it's expressing these schematically shown blue dopamine receptors. And as I say, normally what happens is hypothalamic dopamine comes down the pituitary stalk, binds these receptors, and switches off prolactin secretion. Now we can mimic that with cabergoline, And we can do that because cabergoline works just like dopamine. It binds to these receptors in the same way and similarly switches off prolactin secretion and shrinks the tumour. So for this patient, as you can see, she takes her cabergoline, her prolactin falls very, very quickly to almost normal in 6 months, and her vision improves in just a couple of weeks. So very satisfying to treat. Now, I'd been a consultant probably for about a year when this MHRA safety alert came out. And this was a little bit tricky. So cabergoline was, we were told that cabergoline had some issues around fibrosis of heart valves. So in our hearts, we've got valves which need to be nice and mobile to make blood flow through the heart. And we can end up with fibrotic heart valves due to certain medications. And some of those medications are shown here. Cabergoline does bind to the serotonin receptor, which is expressed by these heart valves. And so there was a concern that cabergoline was associated with valvular heart disease. And this, I remember, being quite a stressful time. I do remember GPs understandably phoning me up, local GPs, and saying, you know, what am I supposed to do? I've got X number of patients on our books who are taking cabergoline for prolactinoma. What am I supposed to do with them? And the guidance was quite specific in terms of echocardiography, which is a certain scan of the heart, like an ultrasound of the heart. And we were told that we needed to be doing this quite frequently. And I guess that's got a couple of issues. First of all, there's a cost to all of that. I think there's a financial cost, but I think there's also a huge cost to patients. I think the older I get, the more appreciative I am that unnecessary investigations often causes a lot of stress unnecessarily for patients. So that was the first issue. And then the second problematic bit was that we were told that women who were planning a pregnancy should stop taking cabergoline a month before they were to conceive. And that's tricky because women who have a prolactinoma and a high prolactin will need to take cabergoline until they get pregnant without stopping. So as soon as they stop the cabergoline, prolactin goes up and then they don't ovulate and have a period. So that was a tricky piece of advice, I think, and we didn't really know where to go with that. And so Karim, myself, Tricia, a wonderful colleague who's also here, wrote to the BMJ and said, could we have some evidence before we do this? And then we moved quickly on to try and get some evidence ourselves. And lots of other groups around the world were also doing this. And we showed here in clinical endocrinology, and this was a joint paper with colleagues from St Mary's, colleagues from Ealing, fantastic support from the cardiology department at Hammersmith, and we showed there was no association between cabergoline treatment of hyperprolactinemia, so a high prolactin, and issues with cardiac valves. So that was very reassuring, and a number of studies showed the same. And so I was then invited on the back of that study to join the UK dopamine agonist valvulopathy group. And that was led by Will Drake, a consultant colleague, a professor in endocrinology at Barts. And we showed over a series of large UK studies, again, that there was no association between this drug and valvular heart disease, which was very reassuring. So I now want to turn to clinical problem solving. So our students might watch the TV and feel that you arrive at the end of a bed and you look at the patient and the diagnosis comes to you and then you sort of disappear in a cloud of smoke and you've done the right thing. But actually that's not how clinical medicine works at all. We're much more of a detective. We have to take a history, we have to examine the patient, we then use those findings to think about differential diagnosis, investigations, and then we come to a diagnosis eventually, sometimes slower than others, just in terms of the complexity of the presentation. So clinical reasoning is making a diagnosis, and that's actually very difficult to teach medical students, and that's because lots of clinical reasoning is experiential, but actually a lot of our students are spending time observing. So I lead the endocrinology teaching for undergraduate medicine for the first 2 years, and I've designed a series of interactive endocrinology tutorials to teach clinical reasoning, which are really popular and the students seem to really, really enjoy. And just to remind you that our cohort for undergraduate medicine is more than 350 students per year. So I literally need an army of teachers to deliver these tutorials with me. And many of the people in this room today or online have helped me with those tutorials, and I'm enormously grateful because it's no small undertaking. Karim and I also looked at other ways to try and be very, very interactive in this large student cohort, and have designed a team-based learning exercise using these scratch cards, which look like lottery cards. And the students really, really enjoy this. We do this at the end of Year 1 and Year 2 endocrinology. The room's very, very buzzing, actually, with teams of students scratching frantically off. You can identify who's the clinician, who's going to be the physician, because they're quite slow and deliberate. And then there's the surgeon, the would-be surgeons, who sort of go through it all in 10 seconds. So it's really interesting to see, but I really enjoy the team-based learning that we do. It's been really successful. And we were lucky to be supported by the Society for Endocrinology financially with an award to develop this teaching. And then also I was very fortunate that the Society recognised me in 2022 as an Outstanding Teacher of the Year, which was lovely. And then along the way, I've got students who are doing a BSc in endocrinology as part of their undergraduate medicine degree. And they are fantastic. They're enthusiastic. They want to learn more about research. You love to support them. And actually, this is just a few examples of papers, of clinical questions we've been able to answer with those BSc students supporting that sort of research. And it's been really rewarding for me to be involved with. So one of my other undergraduate education roles is that I'm head of Year 1 for the BSc in Medical Biosciences, or BMB, wonderful team of people, some of who are here today, thank you. And I think what's really special about this course is that we've got a very early introduction, you can see in the second term, to practical laboratory working. And that carries on through the course and then culminates in a research project in the third year. And anecdotally, I've got supervisor colleagues in the Faculty of Medicine who will tell me how well prepared our BMB students are for laboratory working by the third year. But I've told you that when I started in the laboratory, I felt very, very daunted, and I wasn't even coming from school. So I think we started to recognise that our students felt quite intimidated coming from school to the laboratory, and what could we do to support them better? So I think if you sort of think about, it's a long time since I've done a scientific experiment at school, but it's much more protocolized. There's not the bandwidth or the resources often to make mistakes, but some of the best scientific sort of findings and developments have been actually serendipity and mistakes. So I think it's difficult in school to feel that you could be encouraged to make mistakes, but it's definitely what we want our students to feel free to do. And there are some really interesting parallels between cookery and science, and chefs are in fact the scientists of the kitchen, although I always catch myself when I'm saying this because, as my husband would say, I would burn water, so I'm not quite sure what kind of scientist I am, but anyway. So this is just some photographs showing students, lots of these photographs are just sort of post-return after COVID, so masks which wouldn't be relevant now. But there's a set of carefully designed skills that we introduce in the biomedical kitchen in term 1, year 1 of this undergraduate course, BMB. Firstly to say, not me at all in isolation. A suite of people have been amazing collaborators in this work and actually really instrumental in getting it off the ground. But these sort of kitchen episodes are beautifully timed and designed so that they prepare the students for getting back into the laboratory in term 2. And what I mean by that is you've got this student here who is making this very thin jelly. What's the point of that? Well, it's very like the gel for a Western blot that she's going to be making in term 2 in the laboratory. And you've got a student here making yogurt. Well, that's a student who's had to use good hand hygiene, avoid cross-contamination, use an incubator, all techniques which are important for cell culture, which you'll be doing in term 2. So enormously rewarding. A big shout out to the Department of Chemistry, who have been amazing collaborators in this work, but really positive feedback from our students. And this work and other work that I've shown you in education, I was very fortunate to be awarded a President's Award for Excellence in Education in 2023, which was also really lovely. And really important not to forget our postgraduates who also need educating. So about 10 years ago, Karim and I felt that there was definitely a shortage of accessible pituitary teaching for our trainees. I think it was particularly important in terms of cost. A lot of our trainees, they'll all have a fixed study leave budget. You know, a lot of these conferences are very expensive, deplete all their money. And so we've developed something called the Imperial Pituitary Masterclass. It runs every year, has done for the last 10 years. We've changed venue because it's become so popular. And now we run it actually, thinking about that accessibility, we run it as a hybrid meeting so that you can join in person or online. And last month when we ran it, 10 years of running it, we had 250 delegates. So it's really grown. And I'm really proud of it. And thank you for the support from the Royal College of Physicians and the Society for Endocrinology for that meeting. So I was busy doing all this research and teaching, but also I had 3 children. I realise it makes it look like I had triplets, which I didn't, but they are quite tightly packed, okay? So that was my 3 children, and as I say, very special times actually. And then along the way, I was promoted to a reader. This is a card that is still in my office to this day from Kitty, my middle one, to wish me good luck for that interview. And then I've more recently become very involved in public engagement in endocrinology. So I'm doing some work for the Pituitary Foundation. You can see this online lecture that I did. When I did the screenshot for this, suddenly feel terrified that there might be some thumbs down, but luckily there weren't, so that was okay, that was lucky. And so also Karim and I and Debbie, who's shown here, our wonderful clinical nurse specialist, we deliver an annual patient event for London pituitary patients, where we talk about whatever they want to talk about, and that's Debbie delivering some emergency hydrocortisone training. I also work for the Society for Endocrinology in this role, so I'm chair of public engagement for the Society for Endocrinology. So we do lots of different work trying to really provide high quality resources that are trustworthy for patients. We also do some school outreach, which is really satisfying. And I'm on the editorial board for You and Your Hormones, where we provide a lot of robust resources for people to use around endocrinology. And that's really important because we have a lot of misinformation in endocrinology. And just thinking about that for a minute, I guess one needs to be mindful because the internet, social media, you know, it's responsible for democratization of health, and that's really important. But I think what's becoming increasingly difficult for our patients is knowing where to go and who to trust and what's a reliable source. And I've mentioned to you the importance of evidence-based medicine. So this is I think, a really interesting area to be working in. So over the summer, I was involved in an article for The Guardian about cortisol. Now, as I say, if any hormone needed some rehabilitation, it's definitely cortisol, okay? It's having a terrible time, and it's actually a really important hormone. So cortisol gets us out of bed in the morning, as I've said here. It's really important for our well-being. Yes, it does go up in stress, but it's not the cause, I don't think, as to why you get something called a cortisol belly in stress, which is weight gain. That's all over TikTok. I suspect what we probably need to do is take a step back and be a little bit more sort of holistic about stress. You know, for example, when we're stressed, do we gain weight around our tummies because we're not eating very well, or our exercise routine is being disrupted because we're just feeling too stressed and worried to exercise, or too busy? So that was very rewarding. Also, I mentioned that I'm chair of public engagement, and I work with the Public Engagement Committee. Again, we want to really focus on tackling misinformation. So there will be many people either in the room or online who will be coming to our annual endocrinology conference in Harrogate, which is in March next year. And we've designed a really exciting session, so I really encourage you to come if you're coming to the conference, where we want to really focus on misinformation. We've organised a series of really interesting speakers to talk about these areas that are really relevant to endocrinologists, but also to endocrine scientists, and try and then ask them to tell us what area we should be focusing on in public engagement over the next year. Now also, I'm tackling misinformation at a local level, so let me explain this. So this is a WhatsApp group from some of my lovely friends who are in the audience in Ealing, some mum friends, and I was asked about collagen and I was asked about magnesium, and I thought that my responses were very diplomatic, but nevertheless very clear. And it was such an accolade, I felt like it needs to go onto my Imperial College website page, actually. I'm the Martin Lewis of supplements, so there you go. Okay, and so why we're here, of course, is that because relatively recently I was promoted to Professor of Endocrinology, which is really delightful, honestly. But as Waldrit warned me when I was preparing for my interviews for that, the last thing that you need to sound like is that you're going to get your chair and sit on your hands and do nothing. You need to be showing that you're permanently moving and moving forward. So here I am, moving forward, and I've got some really exciting things coming up. So I'm conscious that Mary Morell is online, and I've had this opportunity to work with Mary and these other lovely colleagues who I've worked with before in London to lead the endocrinology teaching at a new medical school that started in Cumbria, just started relatively recently. A wonderful ethos to the school in terms of contributions to the local community. And it's been really interesting for me preparing the learning resources for that. I'm going to go up next month and spend some time there, which I'm really looking forward to. Really interesting, as I say, thinking about, for example, obesity in Cumbria and how to make that relevant. Okay, so the other thing that I've been focusing on is about dopamine agonists and impulse control disorders. So these are all headlines that are taken from papers over the last sort of 15 years or so. The majority of them are about the relationship between dopamine agonists used for Parkinson's disease and something called an impulse control disorder. But the BBC News ones are actually much more recent, and they are from last year. They're talking about another dopamine agonist that's used for something called restless legs. So we know, as I've mentioned, that dopamine is very important in the brain in terms of the regulation of prolactin secretion, but dopamine is also very important in other pathways, including the mesolimbic pathway, where it's involved in motivation and reward. So what is an impulse control disorder? Well, it's repetitive participation, so you can't stop yourself in a reward-driven activity, often to your detriment. So examples would be hypersexuality, compulsive gambling, compulsive shopping, compulsive eating, but there's a plethora of impulse control disorders. And we know that D2 and D3 receptors are expressed in the mesolimbic system, and we know that there's an association, as I mentioned, between Parkinson's and the dopamine agonists that Parkinson's patients take, and we know that those dopamine agonists bind to these D2 and D3 receptors, but we also know that cabergoline does. And if you remember, I've told you that cabergoline is a really important drug for us in the management of high prolactin and prolactinomas. And for the experienced clinicians in the room, we will all have seen a patient taking cabergoline for a prolactinoma, and we'll all have seen what a disaster that can be for a patient. You know, there are stories of patients who have lost their house because they've, had compulsive gambling. So it's really important that we have some idea who's at risk of developing this. And this is just an article a few years ago from the endocrinologist highlighting what a problem this can be. So I have rolled out a national study looking at the psychiatric side effects of cabergoline. All these red dots are participating sites. Very, very grateful to them all because they've given up their time, busy clinical people, to help with this. And I'm really excited to see where this goes and help us answer some questions, hopefully, about how better to manage these patients, certainly in terms of counselling them around the risk of impulse control disorders when we're treating them with cabergoline for prolactinomas. And a thank you to the Society for Endocrinology for grant funding, the Pituitary Foundation for supporting me with the development of the study, and also a group of psychiatrists who have helped both design the study and also helped in terms of how the study is now running. And a big thank you to endocrinologists and to Krish, who has helped me set up the study and get it up and running. I couldn't have done it without any of these people. Okay, so at the best of times, I find it very difficult to look at photos of my children. You know, I think it's such an emotional thing because it's so sort of clear, the passage of time when you look at them. And I sort of look at this top photograph here, and they're so tiny compared to now. And I remember taking that photo like it was yesterday, actually. That was in front of the church where Kevin and I got married. But goodness, what can I say? I'll try and say, I love you, I think you're fantastic, and I love being your mum. Okay, so that emotional bit over. Next bit is just to talk about the shape of this curve, okay? So as you can see, in my early days, I was quite a straight line up, okay? Number of hurdles to jump through. I was able to do that, supported along the way, and I was very, very lucky. Slower trajectory here. Maybe the hoops were slightly further apart to jump through, but also I had my children, and that was really important for me to be able to be flexible, to be able to get to things that really mattered, like sports day, for example, parents' evening. And I'm really grateful to Karim for all the flexibility, because I could not have done that without that flexibility in the workplace. But I'm also really grateful to a series of people shown on this slide. So I know it's such a cliche that it takes a whole village to raise a child, but for me, I could really not think of any other saying about this slide. So obviously my children are bigger now, so if they're unwell, they can stay at home and look after themselves. But when they were tiny, it literally felt sometimes, particularly because the odds are increased the more children you've got, it really literally felt like every week somebody had a fever, vomiting, whatever. And, you know, Kevin and I would get up, I'd say, I've got clinic, Kevin would say, I've got a meeting. And then you think, oh my goodness, so what are we going to do? And so my parents were so good, you know, they're an hour and a half away. It's not like they're on the doorstep. And they'd be up with us, you know, week in, week out, I think, really looking after the children. So I couldn't have done it without them. I just couldn't have kept the show on the road. There are people here who have loved my children like I love them. And then there are some amazing women on this slide, mainly women in fairness, who have really stepped up, particularly on my busy clinical days. So there are days of the week where I've got clinics in the afternoon, and actually it's very difficult to get out on time. You know, you can't say to a patient, I've got to go. And it's very difficult for me to sort of take a child to a gymnastics lesson that always happened to fall on a Tuesday. So there are people on this slide who really stepped in, and it wasn't just occasionally, it was, you know, for months and years sometimes, taking children to gymnastics, music, whatever, and I really couldn't have done it without them. Okay, so I'm conscious that there are some people that are not on these photographs because I couldn't get photos of everybody, but I'm so lucky with the people that I work with. I've got wonderful clinical colleagues. I've got B&B colleagues shown here as well. I'm really grateful to work with all of them. Here's Waljit, who I've already said has been a great friend and mentor, and I've really appreciated that guidance. Professor Marilyn Druce is a colleague from Barts who I know can't be here, but has been so kind and wise, guiding me through the promotion process, so I really wanted to thank her. I'm hoping that my wonderful friend here, Suzanne Norris, who's a professor of hepatology, is online from Dublin. Suzanne and I met when I was at King's Liver Unit as a junior doctor and have been really good friends ever since, and she's been an amazing source of wisdom and support along the way. I have here Debbie and Emma, wonderful colleagues who make my working day much better, and really grateful to have them, known them both for more than 20 years. And then finally, I have got two people with the same initials. And that sometimes causes problems in my diary. So sometimes I write KM away, and then I can't quite remember, is it KM, Kevin Murphy, my husband, or is it KM, Corinne Meeran, my boss? And sometimes I get, that proves to be a little bit, as I say, bewildering. But both KMs need a big thank you. So to Corinne Meeran, thank you. I honestly would not be standing here without you. You've given me such flexibility, support and inspiration, so thank you. And then, goodness, to Kevin, don't know what to say. But thank you for always believing in me, Kevin. Really, really special. Okay, and thank you everybody for listening.
That was truly wonderful. Thank you very much indeed. That was excellent. It says there Q&A. Have you got any questions after that fantastic talk? Absolutely fantastic talk, covering absolutely all parts of life. So thank you very much. Are there any questions online? Let's have a look. I can't believe it. I was going to ask a question. It's all quiet, I think, I hope. Has anyone got any questions? Otherwise, we'll move on to the vote of thanks, I think.
I'll sit down.
Thank you. I'm going to press this button. Right, well, that was amazing, and that was so complete and so wonderful. And I thought I'll just say a little bit, because, of course, to be an advocate, people, you've got to do three things. Research, and you heard so much about so much, why different bits of research that she's done and brought it all together and made it clinically relevant, mixing in the clinical service. Teaching is just something that most people don't do, and she's done it, not just done it, but done it very, very well, and so many different levels. She didn't mention that she also has been head of Year 6 for some years, and now she's going to Cumbria. Okay, who volunteers to do all of those things? He volunteers. That's the thing about having someone like Professor Martin. And then the clinical service, she mentioned, by the way, I just run the pituitary service, but in fact, she commissioned it, because when she started, there were about 10 pituitary services in London, and they've all been deleted one by one, and there are only 4 left, and we are one of them. So thank you, Professor Martin, for keeping, not just having a good service, an excellent service. It's internationally recognized, not just a single service. But there's a 4th quadrant, as you heard, to Professor Martin's life, and that is a wonderful family at the front. She's there for everything, and most people say things like, I'd like to thank my family for never being there, because but here she's done it all. So well done, Professor Martin, for all of those things, and thank you. I'm very proud and honoured to be part of your life and part of your success, so thank you very much indeed. Thank you. And now it's time for some food and drink outside, so help yourselves.